Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So, up to now, in previous sessions, we have discussed about solid mechanics and materials subject. So, in this subject, the entire course is divided into 5 modules, and we have covered all 5 modules. Step by step, we have discussed. First, theory part and problem solving, and question bank discussions, and then definition and terminology. Now, in this session, I want to discuss about outcome based education. So, what is the importance of outcome based education in engineering, and how to map the COs and POs and PSOs of this solid mechanics and material subject? So already you know, in every session, first we discussed about course outcome of each and every topic. So that outcome, so where to map, so how it will come, the outcome attained or not, how to know. So all these things we should discuss. We will discuss here in today's session, the outcome based education. So introduction to outcome based education, that is OBE. So already introduced this one OBE in our curriculum. So what is this outcome based engineering education? It's not what we teach. It is what you learn. So this is important in outcome based education. So what we teach, that is not important. So already we have covered all many topics and sessions we have taken, but that is not important. But how much you learn, what you learn from our sessions, so that is important. So that is called as outcome based education. So then only outcome will come out. We will know whether you achieved or not. That means you learned or not. So various process are there in between this learning process, learning in this OBE education. So OBE is a educational process that focuses on what students can do, or the qualities they should develop after they are taught. What students can do after completion of this all these modules should develop after they are taught. That qualities you should we should build. The type of qualities we have to build. So that is main focus of this outcome based education. So the OBE involves the restructuring of curriculum, assessment, and reporting practices in education to reflect the achievement of high order learning and mastery rather than accumulation of course credits. So you can accumulate the course credits after completion of your BTech graduation degree, but that is not important. So that is how much achieved. What is your achievement of high order learning? You should master it in our field. So that's why it involves the restructuring of curriculum based on your outcomes, based on your feedback. Again, we will restructuring the curriculum, assessment, then reporting practices in education. That will reflect the achievements. So your both structures and curriculum are designed to achieve those capabilities or qualities. So a model education whereby students demonstrate what they know and are able to do whatever the required outcomes are. So an approach that focuses on students learning rather than teaching. So that an approach that focuses on students, so learning rather than teaching. The student demonstrate what they know and are able to whatever the required outcomes. So the outcome based education addresses the following key questions. One is, what do we want the students to have or be able to do? Why do you want them to learn it? Why should study? So what do we want the students to have or are able to do? What we are expecting and what they are expecting. These points, these type of questions addresses the OBE. And how can we best help students achieve it? So if not achieved, any CO. So how can we best help to the students to achieve their goals? How will we know whether the students are achieved or not? So we should know the students reached or not. So how do we close the loop for further improvement? So after achievement, so how do we close the close the loop for further improvement? So continuous quality improvement, that is CQI. So after assessment, so there is a continuous quality improvement, that is CQI. See, in this, principles of OBE clearly mentioned. One is design down and clarity of focus, and then high expectations and expanded learning. So the major principles of OBE outcome based education are these four: design down, clarity of focus, high expectations, expanded learning. So one by one we will see. So what is this clarity of focus? So first design down we will see. It means the curriculum design must start with a clear definition of the intended outcomes that students are to achieve by the end of the program. Once this has been done, all instructional decisions of teaching and learning are then made to ensure the achievement of the intended outcomes. So the design down means the curriculum design must start with a clear definition. Intended outcome that students are to achieve by the end of the program. So that's why you should define clearly, like a problem definition, what students are to achieve by the end of the program. So these points comes under design down. Next, clarity of focus. Teachers must be clearly focused on what they want students to know. The teachers must be clearly focused on what they want students to know, understand, and be able to do. So, in other words, teachers should focus on students to develop the knowledge, skills, and personalities that will enable them to achieve the intended outcomes that they have been clearly defined. So, teachers must be clearly focused on what they want students to know. That is clarity of focus. Next, high expectations. So, teachers should establish high challenging standards of performance in order to encourage students to engage deeply in what they are learning. Teachers should establish high challenging standards of performance in order to encourage students to engage deeply in what they are learning. So, helping students to achieve high standards is linked very closely with the idea that successful learning promotes more successful learning. So, these are expectations helping students to achieve high standards. So, that is very closely linked with the idea. So, that successful learning promotes more successful learning. Next, expanded learning. Teachers must strive to provide expanded opportunities for all students in learning. So, this principle is based on the idea that not all learners can learn the same thing in the same way and in the same time. Provide expanded opportunities for the students, for all students. So, this is based on the idea that not all learners can learn the same thing in the same way and same time. You should provide different times, different learning sections, and different timings. So, however, most students can achieve high standards if they are given appropriate opportunities. These, these points comes under expanded learning. So, these are the four principles of OBE, outcome-based education, designed on clarity of focus, and then high expectations and expanded learning. Next one, characteristics of OBE curriculum. So, what is this characteristics? Program objectives, and then program outcomes, and then course outcomes. What is the program main objectives? What is the program outcome? PEOs and POs and COs and PSOs, program specific outcomes. So these are the characteristics of OBE curriculum. And the components of OBE. So how many components are there in OBE, outcome based education? One is instruction. After instruction, assessment tasks, and then curriculum. So first curriculum design, assessment task, and instruction. So these are the three components of OBE. The bigger one is curriculum. The smaller circle that is assessment, very small is instruction. So the curriculum design is very very important in this OBE. Next, a model hierarchy of outcomes. One is vision and mission of the institution or faculty. So you have to define the vision and mission of the institute and also department. And then the faculty also should have that vision and mission. And then program educational objectives, that is PEOs. Next, program outcomes, POs. Next, learning outcomes of all subjects, COs. CLO or CO, learning objects. So this is the model hierarchy of outcomes. Vision and mission of the institution or faculty, and program educational objectives, PUOs, and program outcomes, and learning outcomes, that is learning outcomes, COs of objects, subjects. These two are connected with long-term outcomes, vision and mission of the institution, and program educational objectives are long-term outcomes. The program outcomes, PO, and learning outcomes of subject is short-term outcomes. These two are connected with the short-term outcomes, and the two are long-term outcomes. Now, assessment loop. So we will close the loop with continuous quality improvement. First, you take stakeholders' mission and vision and define program objectives, program outcomes, and the learning outcomes of subjects. So, in program objectives, after defining the program objectives, do assessment. And then after assessment, based on the assessment results, conduct continuous quality improvement, CQI. Similarly, program outcomes, assessment, and then CQI, quality improvement, continuous quality improvement. And similarly, learning outcomes of the subjects, course learning outcomes, CLOs or COs. Do assessment, analysis, and then continuous quality improvement. So here, each and every objective or every stage, there is a assessment. Based on this assessment, how to do the analysis, the result analysis, assessment analysis. So then only we can say that those targets are achieved or not. Based on the analysis, we will conduct continuous quality improvement sessions, each and every stage. So now, up to here, what we have discussed about OBE, outcome-based education. So how to do the analysis and how to take the assessment, and then so how to define this outcome-based education. What is the importance of outcome-based education? What are the major principles of OBE, outcome-based education? Discuss. Now, coming to our subject. So the solid mechanics and materials. The course overview, first you should write the mechanics of solids, provide students an understanding of deformation of rigid bodies under static low conditions. It covers the concepts of engineering mechanics of materials and the behavior of materials, components under applied load. The purpose of the course is application of strength of material concepts with respect to mechanical engineering design and analysis. So this is the course overview. So it covers concepts of engineering mechanics and material concepts, and behavior of materials under different loads, how they will deform, how they will act whenever the material is subjected to some load. It may be tensile or compressive or shear or impact. So the purpose of course is the application of strength of material concepts with respect to the mechanical engineering design and analysis. Next, mainly the course objectives are the students will try to learn. First objective is the concepts of stress analysis, theories of failure, relationship between mechanical and metallurgical properties to design and analyze commonly used machines. So already we have discussed in our previous sessions about these objectives. So once again we recall and then see here the second objective is the variations of normal and shear stress, slope and deflections throughout the span, and a cross section of solids in relation to the applied loads. The third one is the theory of fluid torsion, bending to draw, analyze, shear stresses distribution diagrams, circular shaft, and bending moment distribution diagrams in various cross sections of beams for different loading conditions. That is the third object. So after the students in this course, the students will try to learn. This one is course outcome. At the end of the course, students should be able to first CO1 explain the concepts of stress strain, material constitutional relationship, and strain energy induced in linear, elastic, homogeneous, and isotropic materials subjected to forces. And CO2 illustrate the shear force and bending moment distribution in beams for analyzing the structural behavior under various loads. So explain the concepts of stress strain. So this CO1, after completion of this course, end of the course, students should be able to illustrate the shear force and bending moment diagrams. Already they have learned in a shear force and bending moment the topic. And CO3, students should be able to analyze the theory of simple bending for illustrating the distribution of bending stresses across the section beams under loading. CO4, make use of maximum shear stress and shear strain distribution, shear stress distribution across the depth of symmetric and unsymmetrical beams loaded with various loads for the safe design of aircraft components. CO5, utilize Maxwell's reciprocal theorem. Already we have derived in theory session. And double integration method and moment of area method for determining the slope and deflections. Similarly, CO6, at the end of the course, students should be able to demonstrate the principal stresses, principal planes, and torsional stresses acting on any arbitrary plane within a structure using analytical and Morse circle method. Already we have covered these two topics, the analytical method and Morse circle methods in theory session, and also we did problems also. Clear? And recently in previous session we have covered definition terminology related to this Morse circle methods and principal stresses. So that the course outcome is the completion of this course, students should be able to demonstrate the principal stresses and the principal planes and principal strains, and also the analytical and more circle methods. Next, program outcomes. The program outcomes already there are 12 program outcomes. So PO1 engineering knowledge, PO2 problem analysis. So the engineering knowledge, apply the knowledge of mathematics, science, engineering fundamentals, what we have learned in previous class. The engineering specialization to the solution of complex engineering problems. So problem analysis, identify, formulate, and review research literature and analyze complex engineering problems, reaching substantiated conclusions using first principles of mathematics, natural science, and engineering science. So this is PO2, the problem analysis. Next, PO3, the design and development of solutions for complex problems and design system components are process that meet the specified needs with appropriate consideration for the public health and safety and the cultural society and then environmental considerations. The PO4 conduct investigations of complex problems, use research based knowledge and research methods including design of experiments, analysis and interpretation of data, and synthesis of the information to provide valid conclusions. So use research based knowledge and research methods including design of experiments and analysis of interpretation of data comes under this conduct investigation of complex problems, that is PO4. Next, PO5 is modern tool uses, create, select, and apply appropriate techniques to solve the complex engineering problems. So modern engineering and IT tools including prediction and modeling to complex engineering activities. PO6 is the engineer and society. So apply reasoning for informed by the constitutional knowledge, to assess the societal and health safety, legal and cultural issues, and the consequent responsibilities relevant to the professional engineering practice. That is comes under engineers and engineer and society. The PO7, that is environment and sustainability. So understand the impact of the professional engineering solutions in a societal and environmental context and demonstrate the knowledge of and need for sustainable development. So environmental and sustainability goals comes under PO7. The PO8, that is ethics. Apply ethical principles and commit to professional ethics and responsibilities and norms of the engineering practice. PO10, communication. So communicate effectively on complex engineering activities with the engineering community and with the society at large, such as being able to comprehend and write effective reports and design documentation, make effective presentations, and give and receive clear instructions. So communicate effectively on complex engineering activities This is comes under PO 10. PO 11, project management and finance. Demonstrate knowledge and understanding of the engineering and management principles and apply these to one's own work, a, a member and leader in a team to manage projects and in multidisciplinary environments. So project management and finance, so demonstrate knowledge and understanding of the engineering and management principles. So all these things apply to one's own work, that is project management and finance. Next, last outcome, that is program outcome PO 12, lifelong learning. Here recognize the need for and having the preparation and ability to engage in independent and lifelong learning in the broadest context of technological change. So this is PO 12. Now we will discuss how program outcomes are assessed. So already we have seen 12 program outcomes are there. So which program outcomes are related to our subject? So that is solid mechanics and materials. Like that, you should select the program outcomes and then assessment methods. So will you assess? Here, 3 program outcomes are identified for our course. So in PO 1, already you know that is engineering knowledge. This is common for every subject. Why? Because whatever you learn, the physics principles or mathematics or science, you should apply for your complex engineering problems. So fundamentals and an engineering specialization to the solution of complex engineering. The strength is 3. So here given the 3 is high and the medium is 2 and 1 is low. The proficiency assessed by end examinations, mid examinations and AAT tools. Alternative assessment tools. So by conducting these proficiency testing, after that assessment will be completed and then we will start the continuous quality improvement. Already shown in diagram. Next year, second outcome PO 2, program analysis. So the strength is 1, so that is very low. So why? Because it identify, formulate, review research literature and analyze complex engineering problems. Clear? So here we are not doing any research. So here mentioned for this outcome, less importance, that is 1, and assessment methods are same. PO 3, design and development of solutions. This one also since the design solutions for a complex engineering problems and design system components or process that meet the specified needs with appropriate consideration for the public health and safety and the cultural, societal and environmental considerations. So assessment strength is 1 and assessment methods are SCE, CA and AAT. So like this you have to frame the table. Next, specific outcome. How program specific outcomes are assessed. See, department ways it may the specific outcomes may vary. So the program outcomes. So formulate and evaluate engineering concepts of design, thermal and production to provide solutions for technology aspects in digital management. This is program specific outcomes, the mechanical department specific outcomes. The strength is 3. The proficiency assessment is research papers and industry exposure. Similarly, PSO3. So make use of computational and experimental tools for creating innovative career paths to be an entrepreneur and a desire for higher studies. This is comes under program specific outcomes, that is PSO3. The weightage is 3. The 3 here mentioned here, the strength weightage is 3 is for high, 2 medium and 1 low. So program specific outcomes defined, and then program outcomes also defined. Now the mapping. So mapping of each CO with POs and PSOs. COs also defined. So course outcomes. Total 6 outcomes are there. Already we have discussed. Once you go back and see 6 COs. So 1, explain the concepts of stress strain and material constitutional relationships. Clear. And CO2 is the illustration of shear force and bending moment. And 3 is the analyzed theory of simple pure bending for illustrating the distribution of bending stresses. Make use of maximum shear stress and shear stress distribution across the depth of symmetrical and unsymmetrical beams. CO5 is utilize Maxwell's reciprocal theorem for slope and deflection calculations. Double integration method and a moment of area method for determining slope and deflections. So demonstrate the principal stresses, principal planes and torsional stresses acting on any arbitrary plane within a structure using analytical and Mohr circle method. So these are the course outcomes. Now mapping, PO also we discussed. The mapping of each CO with the POs and PSOs. The course outcome written in the first column, CO 1, 2, 3, 4, 5, 6, total 6 COs are there. In horizontal, total 12 POs are there. So already we have discussed about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And PSOs also we have discussed 3 PSOs are there. PSO1 and PSO1 and PSO2 and PSO3. The strength given here 3, 2 and 1. So according to the weightage, you should map with these POs. The CO1 mapped to 1 and CO2 is 1 and 3 and CO3 is 1 and 2. The CO1 is mapped PO1. What is PO1? PO1 already all COs mapped. So why? Because this is engineering knowledge. The CO1 and CO2 and CO3 up to CO6 and next one is CO3 mapped to PO3, PO2 and PO3, CO4, CO5, PO3. So like this, how to map the course outcome with program outcomes and PSOs. So finally, we will calculate the outcome of this course or outcome of this course. This is course wise. So like this course wise, we will in department they will segregate and finally they will analyze and they will give result about their outcome achievement, whether student achieved or not. Not achieved means continuous after assessment take continuous quality improvement. So then only the outcome will achieve. So this is the mapping. This is outcome based education main aim. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.